Hey guys, this is part one of preparing solutions. I split this up into two videos just because of the amount of example problems and just how long these videos will be. So the first video, this is going to cover the first two example problems, basically first page and a half. So when we are preparing solutions, say we are in the lab, it's kind of our responsibility to be able to make different concentrations of substances and being able to calculate that on our own. Okay. So for instance, if we think about human blood plasma, so this contains a very specific amount of molarity of dissolved salt. So if we have or injected with intravenous or IV solution, where we're donating blood or we're receiving blood, it's imperative that the concentration of the blood matches the concentration of blood of our body, right? And for that, the concentration of salt needs to be about 0.15 molarity. So anything else, and that can prove harmful to our body. And we've talked a lot about toxicity and lethal dose, and these things, if they don't match up, can be dangerous and harmful. So it's important for us to be able to figure out and calculate molarity for different solutions and be able to prepare solutions kind of using converting units. Okay, so say for instance we are in the lab and we had to create a solution, and you need to make a solution or 0.15 molarity of sodium chloride solution. How should this be prepared? Okay, so remember, just kind of review from the previous videos, our 0.15 molarity can also be rewritten as 0.15 moles over liters. Okay, and so what we need to do is take this 0.15 moles over liters, and we need to convert moles to mass using the molar mass of the compound, which in this case is sodium chloride. So we're going to go to the periodic table, and we're going to look for sodium, which is right there, and chlorine, which is right here. Sodium's 23, and that's 23 grams per 1 mole, and chlorine is 35.45. Okay, so we take those two numbers and we add them up, and we should get 58.45. Okay, and that, again, that is our molar mass, so grams over moles. So what do we need to do here? We need to multiply, right? Because we need these moles to cancel out, and what we're going to be left with is grams over liters. So we take 58.45 and we just times it by 0.15, and we get 8.767. We'll just round that to 8.77. And again, the units, that's grams over liters. Right, we're taking that one and that unit. Okay. So that number basically means in a 1 liter solution, we need to add 8.77 grams. So if you dissolve 8.77 grams of sodium chloride in water so that the total volume of solution is 1, you will have a solution that is 0.15 molarity or 0.15 moles over liters. And that's what we can see here. So you would have a mass or scale, you'd weigh out the sodium chloride on the scale and then just dissolve it in the water. Okay. Important thing to know, when you dissolve one substance in another, they both take up space. So to make 1 liter of an aqueous solution, you add less than 1 liter of water. Right? So we have some amount of water here. We add the salt, or 8.76 grams first, and then we fill up the remaining liter we need with water. Basically, that just means we want to take into consideration that salt has a volume and it takes up space. So we don't want to just add 1 liter of water first and then put the salt in. That will not be as accurate. And as scientists, we strive to be accurate. All right, so let's go to the next example problem. So a dextrose solution. So sometimes doctors can administer an IV solution containing a solution of dextrose to a patient who has low sugar or high sodium in the bloodstream. Dextrose is a type of sugar. The structural formula for dextrose is shown in the illustration here. And the IV solution contains 150 grams of dextrose and 3 liters of solution. What is the molarity of solution? So we are trying to find the concentration. And to start, we're going to take that 150 grams of dextrose divided by 3 liters, and we're going to simplify that, right? Because we usually want to be dealing with a certain amount of grams over 1 liter, right? So we want to make this into 1 liter. So we do 150 divided by 3. We get 50 grams per 1 liter. Okay, so that is how much dextrose is in that solution, or there's 50 grams for every 1 liter. The next thing we need to do is to find the molar mass of dextrose. And if you see there's no chemical formula anywhere, we're going to have to find the chemical formula. Okay, so remember in kind of models, the black spheres are carbon, red spheres are oxygen, and the white spheres are hydrogen. So we're just going to do some counting. We'll start with carbon. Carbon has 1, 2, 3, 4, 5, 6 atoms in there. Hydrogen. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogen. And then oxygen, 1, 2, 3, 4, 5, 6. 6 oxygen. All right, so with that empirical formula, we could get our chemical formula. And now we need to find the molar mass. So we have 6 carbon, and carbon, if we looked on the periodic table, has a molar mass of 12. That will get us to 72. Next we go to hydrogen.